Cross-cloud infrastructure migration requires accurate translation of resource definition, consistent configuration adjustment, and thorough validation of parity between environments. Manual approaches introduces risk, notably misconfigured resources, broken dependencies, or environment drifts that can cause downtime or operational issues. This is exactly where FluidCloud comes in, providing a reliable solution by automating the translation and provisioning of infrastructure through API and Terraform based workflows. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and in today's Tech Talk, we will explore how FluidCloud ensures seamless infrastructure transitions into Vultr while preserving fidelity of compute, networking, and security setup. We'll also cover what it is, its core capabilities, and wrap it all up with a hands on demo that shows the migration process in action. So, without any further ado, let's get started. Vultr has joined hands with FluidCloud to simplify multi-cloud infrastructure migration and orchestration. FluidCloud functions as a control plane, enabling you to migrate infrastructure without rewriting or re-architecting your stack. It ingests infrastructure definitions, normalizes them into a consistent model, and provisions equivalent infrastructure on Vultr. The platform maps elements like routing rules, firewall configuration, and compliance driven segmentation and then replicate them in Vultr with equivalent settings. This eliminates configuration drift that typically arises during manual provisioning. FluidCloud delivers tangible operational advantages by tackling the core challenges of multi-cloud migration. It accelerates migration timelines by automating infrastructure translation and deployment, reducing manual work and minimizing the risk of error. By enabling one-click migration, it breaks vendor lock-in, giving teams the flexibility to easily reprovision their infrastructure on Vultr. The platform also enhances resiliency by recreating complete environments, including networking and security configurations to support failover and backup use cases. Finally, FluidCloud standardizes infrastructure using Terraform, producing reusable and version controlled templates, ensuring that deployment remain consistent and repeatable across environments. Let's now walk through how FluidCloud manages the infrastructure migration. To initiate a migration with FluidCloud, you begin by securely connecting both your source and target cloud accounts to the platform. This involves setting appropriate read and write permissions based on your organization's security policy. Once the accounts are connected, FluidCloud automatically discovers the existing infrastructure resources on your accounts. For example, compute instances, storage volumes, and networking components. For migration, the inventory is presented back to you, giving full visibility into what exists in the source environment. You can then cherry pick specific resources you wish to migrate, which leads to FluidCloud provisioning the equivalent infrastructure in the target account using API and Terraform based engines, preserving configurations and interdependencies to ensure the recreated setup function as expected. It's also important to note that application binaries, live processes, and database contents are not automatically transferred. Those require separate data migration steps, which you can perform before or after reprovisioning. Now let's move to the demo. We'll use FluidCloud to migrate infrastructure from AWS to Vultr. We'll see how the workflow detects existing resources, how we can select the infrastructure to reprovision, and execute the translation pipeline. Finally, we'll validate that the recreated environment on Vultr matches our intent. We have a demo FluidCloud account already set up, so let's begin by connecting our source and target environments. In the FluidCloud console, under the account section, you can add multiple providers with appropriate credentials and configured permissions. First, let's click on Add Account to configure AWS as our source environment. FluidCloud requires the necessary read-only access to discover compute, networking, and storage resources in your AWS account, and elevated write permissions to perform migration and provisioning of resources. So please ensure you have all the access policies in place. To proceed, assign a unique name to your account. Further, provide your AWS account ID. Once done, create an access key in AWS and supply the corresponding secret access key here. Finally, select a region you want FluidCloud to scan. Once all the credentials are entered, click on Add Account. This will make your AWS account available for migration, and FluidCloud will automatically fetch all the existing resource inventories. Now let's add Vultr as our target environment. For that, first switch to the Vultr customer portal and head to API section under Other in the account settings. Enable API access if you haven't already. This will generate a default API key for you to use. Copy it and store it securely. Next, scroll down to Access Control List and enable Allow All IPv4 for FluidCloud to authenticate successfully. Once done, return to the FluidCloud console. Here, click on Add Account and select Vultr as the provider. Assign a unique display name to your account, provide the email address linked to your Vultr account, and paste the API key. Finally, select a region where you want FluidCloud to provision resources. Once everything is configured, click on Add Account. Now, FluidCloud is authorized to orchestrate infrastructure deployment directly into Vultr. Now, there are two ways to perform a migration in FluidCloud. Once your AWS account is connected, click on View Account to see the full inventory of discovered resources, such as EC2 instances, EBS volumes, network interface, subnet, VPC, security group, and so on. From here, switch to the Migrate tab, and here choose a target. In this case, it will be Vultr. Further, choose a target region where you want FluidCloud to provision the infrastructure. As you can see, upon selection, FluidCloud has mapped the AWS resources to their closest equivalents on Vultr. At this stage, you'll also get a cost comparison overview reflecting the estimated differences in monthly spend for the same infrastructure on both the providers. Once satisfied, click on Create Migration and enter the migration details, which in turn will create a draft migration workflow which will appear in the migration section. Another way to perform a migration is to start directly from the migration section. Here, click on Begin New Migration to create a fresh workflow, provide a descriptive label here, and select a migration type. In this demo, we'll go with Cloud. Further, let's configure our source. Select AWS as the source environment and choose the linked AWS account. Once done, pick the resources you want to migrate. For example, VPC, EC2, security group, subnets, and then click on Configure Target. Here, select Vultr as the target environment and choose the connected Vultr account. FluidCloud will generate visualization preview based on our selection. As you can see, it beautifully maps the AWS resources to the corresponding Vultr infrastructure. Once verified, click on Create Migration button. This will populate our migration workflow in the draft stage. To finally act upon it, click on this migration. This view is similar to what we were looking at while talking about our first approach to migration in FluidCloud. It provides a side-by-side cost comparison, highlighting potential savings, and it is highly predictable. When resources grow, the cost efficiency becomes even more significant when migrated to Vultr. Now, behind the scenes, FluidCloud also generates Terraform templates, representing the translated infrastructure. These templates are version controlled and reproducible, which you can download using this download button for review. Let's take a quick look at the Terraform snippet generated by FluidCloud. You'll see a Vultr Cloud Compute instance created from an AWS EC2 instance, a Vultr VPC translated from an AWS VPC, including a CIDR block, a TLS private key resource for deployment dependencies, and a firewall group recreated in Vultr from the AWS security group. This allows you to see exactly how FluidCloud provisions the infrastructure without manually configuring anything. Back on our FluidCloud console, to apply the Terraform configuration, click on Launch Migration. You can monitor the progress using the progress bar here. Once the migration completes successfully, we can switch to the Vultr customer portal to verify that all resources have been provisioned correctly. In the compute section, you can locate the instance provisioned via the FluidCloud migration. In the firewall section, the security group from AWS has been recreated in Vultr as a firewall group with the instance attached. Finally, in the VPC network section, you can see the migrated VPC retaining the original CIDR block, confirming that AWS network setup has been accurately translated and reproduced in Vultr. And that's how FluidCloud enables seamless infrastructure migration from any supported cloud provider to Vultr, preserving compute, networking, and security configurations while providing a clear cost comparison and reproducible Terraform templates. To follow along at your own pace and practice these steps, please refer to the supporting reference guide linked in the description below. And that wraps up our tech talk on migrating infrastructure to Vultr using FluidCloud. We have seen how it streamlines migration, preserves configuration, and provisions environment with high reliability. We highly encourage you to explore FluidCloud with your own environments on Vultr and experience the streamlined migration process firsthand. To experiment with deployment, you can claim $250 in free credits on a new Vultr account using the promo link attached in the description below. For further guidance, troubleshooting, or sharing insights, visit the Vultr Community Forum to connect with other developers and operators. Thank you so much for joining this Tech Talk. We hope to see you in the next one.